In this section, we're going to learn how to create even more advanced shaders, how to customize some of the values, and how to create interactions to enable or disable those shaders. Now we're going to start by organizing a little bit our code. In this case, I want to set the Z stack to be a component. So basically, I'm going to select the whole Z stack. I'm going to call that layout and then cut that code, create var layout of type SumView, and then paste the entire Z stack without the additional properties. So here we have the main body and then the layout and then the frame as well as the distortion effects. So let me just indent this code, and this is what we have so far. Now for the complex wave, we're going to use a modifier called visual effect. And this is where we're going to use the content and then apply the distortion effect. This seems to be giving us a sample code. And in this case, we can just ignore it. But I guess you can understand that we have the content and then we have the offset. We're getting a value also called geometry proxy, which we can shorten to something a little bit shorter like proxy. And now we're going to use content. And with that content, we're going to apply the distortion effect. Let's start by setting the shader library, then calling the complex wave with parentheses. Now we're going to have a lot of values depending on the shader itself. We're going to set that a little bit later. So let's set the max sample offset to 0 for now to see what's going on with that. Let's focus on the values for the complex wave. I'm going to start with a float and then set 1, then another. This time is going to be a float 2, set as 0.5. And here, if you don't know the number, you can just use either from the sample code or just use a placeholder number. In this case, I can just use 1 for each until I get something. What you're noticing is that the float 2 has a different type of value, and it seems that we can use something like a CG size, which would accept the width and the height, for example, 100 by 100, and see what's going on. And this is where, as you get better with code, you're going to explore more of these value types and how to convert between each. In this case, the float 2 seems to be accepting a CG size. So now let's play with some of the values. So for example, I'm going to set the third value to 0.5 and then 8. And I'm starting to see some stuff going on here. It's really interesting to play with that. And then let's see the first value. I'm going to set it to 10. And you can see really a lot of interesting things. But right now, it's not doing the animation that I want. So let me try something more drastic. I'm going to use the start date time interval since now. Oh, so now we're starting to get more animation going on. And perhaps the size can be changed as well. Okay, so a bigger size seems to create more of these waves to apply to the whole thing rather than isolated by pockets. And now I can try to use the proxy value that I'm getting from visual effect. If you've done geometry reader before, you'll know that using that type of value is going to provide the size, which I can replace the CG size with. All right, so I'm getting what I'm looking for, and it seems to have that cropping issue. So I'm going to increase the max sample offset using, again, a CG size and the width of 100 and height of 100 as well. Now it's clear that we have some issues with some of the elements, which we're going to fix later. But for now, I want to do one last shader, and this is where it's from one of the blogs, and you can get a code from the blog itself, which is also something that was based on shader toy. So we're going to take a look at that. Obviously, the code is a little bit different from Shader Toy. This is where I think GPT-4 can really help in the future. I tried to convert it, but without success. Maybe with a little bit more experience with this type of code and with the help of GPT-4, that's going to be getting better with time. We're going to be able to easily convert any of these really cool shaders that I look forward to using. So I'm going to use their shader code. And again, it can be any shader code that you're going to find online. So I'm going to use this one, go back to my shaders file. This is where I'm going to paste it. So here I see that the name is circle loader and we have some colors going on. So let's test this first and then maybe we can customize that. So now I'm going to apply that to the image itself. So we can do that maybe before the overlay, which is the noise shader. So this one happens to be a color effect. And I'm going to use shader library, circle loader, which is the name, parentheses, and taking from their sample code, it seems to be using a bounding rect, and it seems to be the value that is the size of the shape that this shader is attached to. So that would be the image. And then right after bounding box, we're going to set a comma and then set a float with a number 1. Again, I like to do that as a default value. And right now, you don't see much going on because of the other ones. You can always disable them using commands. And I'm selecting those ones. And now I have this one left. It's just that there's no animation. And the reason why there's no animation is because this is a static value. We're going to replace that with start date again, time interval since now. Because it's within the timeline, you can see that it's starting to animate. Of course, with the simple wave and complex wave on top of it. And with this, it's pretty cool. I can try to customize what's going on with the colors. So for example, if I want something a little bit more purple or pink, I can go to Figma. And here in Figma, you can just create a little square and customize the color by using the eyedropper. This is fairly cool. I'm going to use the design code colors, a little bit of purple and maybe a little bit of blue. So I'm going to create a second color and there we go. It needs to have enough contrast between the two to make it interesting. But again, this is up to you. So now I have a hex color value and I want to turn that into the color that is accepted here, which is a float color. Now, again, you can use GPT-4 to help you on this journey. So for example, I can say I want to convert my hex color, which is this one, and I'm just going to specify hex to vector float 4. And so let's see what GPT-4 is going to give me. Okay, so this is what GPT-4 is giving me. It's also explaining what's going on and how it's converting these values. So the final code is this one. We don't really need the declaration. We just need the vector float 4, where we're going to simply replace these two values. So we have the background and then we have the circle. So I'm just gonna replace this, remove the space, and then come back. And then I did that for the second color. So again, copying this code here and then replace that right here. So now we can start testing it, going back to content view and wait a little bit for the preview to load. And boom, we have the colors. So I just wanted to show you that you can be very resourceful and ask GPT-4 for help and try to get more and more complex with converting code. So for example, as you get better, you can certainly try to convert some of the shader code and really have fun with creating something unique. So the next part is to put everything together, because right now we're just applying all the shaders at once because we love learning. But now we need to make this into something that is usable. So what I'm going to do here is that notice that each of the color effect, distortion effect, they have this value called isEnable. And this is where we're going to use it to enable and disable those shader effects. So for example, if I tap on this icon, is going to enable or disable the wave and so on. So first of all, we need to set the states. So I'm going to start by setting the state of has simple wave, and I'm going to set that to false. And I'm going to do the same for the other 5. So let me just duplicate to get 6 of these values and just change them one by one. And there you go. We have one for complex wave, the pattern that we just set, the noise, the emboss, and the pixelation. Since this is a Boolean, usually you would use something like is and then the property, but sometimes is emboss, or you can say also has emboss, and that's entirely up to you. And like this, your code is going to be a lot more readable when you're going to set the condition. I'm going to scroll down a little bit and I'm going to apply that to the distortion effect for the simple wave, and just make sure to select the effect. And if you don't know where it stops, so you can always double click on the parentheses or the curly braces. In this case, it's right before the last parentheses. I'm going to add a comma, and there's a value called isEnable. This is where I'm going to set it to the state has simple wave. So it's going to be false by default, meaning that it's going to disable it. And I'm going to do the same for the distortion effect for the complex wave. So again, isEnable has complex wave. Then scrolling to the image, we have a bunch of them. So let's start applying one by one. Now the color effect is the pattern. So isEnable has pattern. And then we have the noise here, which is isEnable has noise. Emboss, I'm going to set after the max sample, and then has emboss. And finally, we have the pixelation. This one is isEnable is pixelated. One thing I'm noticing here is that it's still applying the rounded rectangle. So even though this color effect is disabled, it still has a rounded rectangle by default with the blending mode. That's why the image is a little bit lighter. So one thing I can do is to apply an additional opacity that is going to have that condition. So has noise (1), otherwise 0. Now everything is disabled by default. So all that is left to do is to apply the event itself. So we're going to use untap gesture. Let's start with this simple one. So I'm going to apply that on the image. So at the end of the image modifiers, and here we have a bit of an indentation problem. So I'm going to fix that. After phase animator, I'm going to set untap gesture and then has noise dot toggle. Now when I click, I see the noise, which is kind of cool. And I want to make it a little bit more obvious. I can use a blending mode overlay. That's pretty nice. Let's do the rest. I'm going to go to the icons. So let's start with the play. And by the way, you can always command click on any of these values. So for example, the play is a component. Command click on it. It's going to go directly to the contents of that component. This one is going to be one of these icons. So the first one is going to have untap gesture and has emboss dot toggle. And I can also make the code a little bit cleaner, especially when it's short. I can set it in a single line. So copy this, and then I'm going to put that on the third icon and paste it. I'm just going to change to is pixelated. So I can test that. The first one is going to emboss and the second one is going to pixelate. All right, so for these 3 icons, I'm going to use another navigation technique, which is to go to this breadcrumb here. So you can always go back to the top or you can just go directly to where you want to go. So for example, in this case, it's called content. And this is where we have this container with the text and the icons. So I'm going to scroll down a little bit to find the icons. So we have the ellipse. I'm going to add untap gesture, and this time is going to be has pattern. The second one, I'm going to apply has simple wave. And the third one is going to be has complex wave. So now we have these three icons that I can enable and disable the different effects on top of another. So notice that the small one, which is the ellipse, it's kind of hard to click on it. And that happens a lot when you apply untap gesture to, let's say, a symbol or a small text. And one thing you can do is to increase the size by using frame. But sometimes with frame, it doesn't necessarily create the actual space for clicking. So if you don't set an actual background color, sometimes you may have trouble. So a better way to do that is to embed this inside a button. So I'm going to embed the image and I'm going to put that inside a button. And typically a button also has an action. So we're going to set curly braces, and then the content itself is going to be label. Now, whatever is inside the first curly braces is where we're going to set the action, which is where we change the state. So I'm going to cut the contents of untap gesture, which we don't need anymore. And this is where if I click on the button, then we toggle has pattern, and then the label itself is the image. Now it's a lot easier to click, and by default, the button is always going to tint the content, and this is using the accent color. If I want to change that, I can set the tint modifier, and I'm going to use primary, which is the default color. So there you go. And we managed to apply these interactions for each of these effects. And I think it's really cool to experiment and to try to implement these shaders effects depending on the interaction, where you go, what transition. And this is where we have so far. Obviously, we're going to fix some of the issues. So before we go fixing this one, which is quite easy, I'm going to go back to the top to find the layout where I'm going to click on it. And what I'm going to do is simply to add an opacity value where it's going to be hidden if I didn't click on the download icon. So what I'm going to do is for animation values, I'm going to set var opacity is equal to 0.0, and then going to the layout where I'm going to find the circle. And this is where we have the keyframe animator. So we have applied the offset and then scale. We're also going to add dot opacity to the value dot opacity that we just set in the animation values. And then here, we also need to set the keyframe track. So right now, the opacity is going to be the 0 all the time. Instead, I'm going to set keyframe track and use dot opacity, curly braces, set a cubic keyframe where I'm going to set an opacity to 1 with a duration of 0. So what this means is that as soon as I click on it, it's going to have opacity of 1 right away. And then when it's finished, it's going to go back to opacity 0. So this is what we have so far. And I really think that it's really cool that we're able to apply all of these color effects, visual effects, animations, and really experiment with the code and see how we can convert some of the shader code. And there's just so many possibilities with shaders. Now, in the next section, we're going to start fixing some of these issues with, for example, the material elements and therefore the foreground style elements and some of these issues. And we're also going to animate the pixelation because right now it's not able to use the timeline values. So in that case, we're going to set a custom animation using a timer instead. So I'll see you in the next section.